statistics? Well, statistics at its core is just a method of collecting, organizing, and analyzing and interpreting data. Statistics breaks into two different branches. We have descriptive statistics. That would be, it's concerned with collecting, organizing, summarizing, and presenting data. Before I continue, before I forget to tell you guys, hey, this isn't geometry right now, right? Geometry was nice because I would just give you a formula and then we do some examples together. This is different. This is more like a traditional type class where I'm not going to write down everything you need to write down. We're going to have discussions. I'm going to say things I don't write down. In fact, there'll be slides where I don't write anything on. That doesn't mean you shouldn't be writing stuff. Okay? So unpause. So it's concerned with collecting, organizing, summarizing, and presenting data. This is stuff you've already done. This is like calculating the mean, the median, the mode. This is collecting data. This is coming up with charts. This is making graphs. These are all prime examples of descriptive statistics. So that's all stuff you could have written down there. These are basically the numbers. We collect stuff. We make charts of them. We make graphs of them. We find means, we find medians, we find key numbers that have to do with it. That is our descriptive statistics. Generally, these are numbers or graphs. Inferential statistics has to do with making generalizations about drawing conclusions from the data collected. These are generally sentences. I look at all of the data and I read into them. I come up with an idea based upon the data I collected. For instance, let's say I collect all of the heights from you and I put it on the board. That's descriptive statistics. Let's say then I find the median of the male heights and the female heights. That would still be descriptive statistics. However, as soon as I say, looking at it, I'm like, guys are usually taller than girls. Then we would have inferential statistic. As soon as I put words to it, as soon as I say guys are taller than girls on average, that is me inferring stuff from the data. That would be inferential statistics. Okay? So that's the difference between the two. These are our numbers and stuff. This is reading into the statistics. Why are they important? What's important about them? And we'll kind of talk about this throughout this whole lesson. All right. The next thing we're going to get to is something called populations and samples. A population is not the entire planet when we're dealing with statistics. Instead, a population is the set containing all the people or objects whose properties are to be described and analyzed by the data collector. So my example of a population would be, let's say I own ABC. And I'm trying to look at statistics on who watches TV on Thursday night or a particular program on Thursday night. What would my population be? Anyone have a guess on that? Yeah.
People that watch on Thursday night.
People that watch on Thursday night. In fact, we'll go one step bigger. Everyone that owns a TV. That's our total possible, right? All the people that could be watching on Thursday night or anyone that owns a TV. So my population would be basically anyone that owns a TV. I'll put everyone who owns a TV. Who has a TV? Now, is there any way I'm going to call everyone that owns a TV and ask them what they watched last night? No, it doesn't make sense. We couldn't actually collect that data. So what we do instead is we come up with a smaller group, a subsection, a subgroup of the entire population. That's called a sample. It's a subset or subgroup of our entire population. So perhaps, rather than calling everyone that has a TV, I'm going to randomly pick 1,000 people I'm going to call. So our sample could be random 1,000 people that have a TV. So we start with a big population, and then we make that smaller so that I can actually deal with that. Yeah?
So is that why it's like 9 in 10 dentists?
Dentist sizes?
Yeah. Dentists recommend this toothpaste.
We'll talk about that in a second.
Oh.
We'll talk about that in a second. But yes, that's exactly what they'd be doing. Because they didn't poll every dentist in America. They didn't send out this giant thing. What they did is they just interviewed or randomly selected 1,000 dentists and asked, how many of you guys, prefer this brand? All right, let's get down to example 1. It says, a group of hotel owners in a large city decide to conduct a survey among citizens of the city to discover their opinions about casino gambling. So what's probably happening in the city, and it happens at lots of cities, is they're deciding, do they want to actually legalize casinos or gambling within their city? And that happens more often than you'd think. So they want to know, this hotel owner wants to know, in this large city, do people actually like gambling? What would my population be? Life.
The amount of citizens in the city.
Yeah, all of the citizens that are in that particular city. Make sure I didn't miss anything along the way. Nope. So this would be all, and I'm going to make sure to underline all citizens of the city. Now, I write all, and I underlined it, but do I mean like infants? No. We have to infer that we got to know what they're talking about, right? It's got to be people that understand the casinos and could possibly gamble. All right. We're going to all citizens of the city. All right. Here's what the hotel owner does. So one of the hotel owners suggests obtaining a sample of surveying all of the people at 6 of the largest nightclubs in the city on a Saturday night. Each person will be asked to express his or her own opinion on casino gambling. Does this seem like a good idea? Is that a good way to get a feel of how the city feels about casino gambling? Yeah. Say that again? I'm sorry.
Wait, doesn't it say isn't all the people that have been gambling before, so it kind of presumes it must
Oh, I don't know. It just says a nightclub on a Saturday night. They're just going to pick people at a nightclub on a Saturday night. And they're asking them, Hedge?
I mean, they're at the club, so. No.
So no?
Yeah.
Why not?
They might be, I don't know,
They might be what?
biased, because they're
Don't you think they'd be biased? What do you think?
They should have asked all the adult population of the town instead of just those 6 nightclubs, because there could be people who aren't there who would still have an opinion on the subject.
Absolutely. Do you think people at a nightclub on a Saturday night have different opinions than a person that's going to church on a Saturday night? I'm not saying they definitely would, but do you think they'd have a different impression on gambling? What would you think? What would you think the skew is of people going to nightclubs on a Saturday night? How do you think they feel about gambling? Sedge.
It's good.
What was that? It's good. It's probably good. You will probably get a good skew of people saying casinos are good. But like Stephanie said, does that represent the entire population of that city? No, it doesn't. So Stephanie said we need to bring more people in and ask them. This is a completely biased sample. Who would probably like this sample? Yeah. The people that gamble or the people that want to put casinos in. They're going to go, okay, we did this sample. 99% of the population loves casinos. Let's go ahead and build one. This goes into what Life was saying about 9 out of 10 dentists prefer a toothpaste, right? Do they ever say what their sample size is?
No.
Do they ever say who they sampled?
No.
We don't know. Could it possibly be these are all dentistries that are sponsored by, maybe Colgate owns some dentist places, and they sponsored the survey? Bias. Look at every dentist. Every dentist or every toothpaste commercial says 9 out of 10 dentists prefer this brand. How does 9 out of 10 prefer every single brand? Right? So think about that next time you're given data. What was the sample? Was it biased at all? So no, this would not be a good idea. It'd be biased towards getting a casino. Once again, this is something I didn't write anything on, but I see most people wrote stuff on it. You should have stuff down for that. All right, random sampling. That leads us to random sampling. It's kind of where Stephanie was leading us to. This says there is a way to use small sample to make generalizations about a population. We need to guarantee that every member of the population has the same, has the equal chance, I forgot how I put it, has an equal chance to be selected for the sample. Sampling people at 6 of the city's nightclubs does not provide this guarantee. Just like Stephanie said, we need to involve all the adults. This involved one subsect, people that go to clubs on Saturday night. This is called random sampling. A random sample is a sample obtained in such a way that every element in the population has an equal chance of being selected for this sample. When I pick a nightclub at a certain time, not everyone has a fair chance of getting it because most people don't go to the nightclub on Saturday night. It's probably like a 10% of people do that. All right. We're going to get to one more term here. It says surveys and polls involve data from a sample of some population. Regardless of the sampling technique used, the sample should exhibit characteristics typical of those possessed by the target population. This type of sample is called a representative sample. So when we have a sample that really represents our entire population, all the way across our spectrum, that is called a representative sample. That means I did everything right. It represents everyone. I got a pretty good idea. Maybe I get the polls in and 40% of people like gambling. I'm pretty confident it reflects our entire population. Let's not build casinos. All right? Versus this one, when we pick 6 nightclubs, I bet you'd have like 90-some% supporting casinos. Let's build casinos. You're going to get 2 different things if you have a total representative or if you just pick one that favors what you want to happen. Let's go back to this really quick. Let's not. We don't have a ton of time. We have shortened classes. All right, example 2. It says, we return to that hotel owners in the large city who are interested in how a city feels about casino gambling. Which of the following would be most appropriate to select a random sample? On the homework, I'm just expecting you to circle the correct one because you have ones just like this on the homework. For your notes, you have some space so you can write stuff in. So you can write in why it's not a good idea. All right, so let's go with the first one. It says randomly survey people. It says randomly survey. That's good for random sample. It says randomly survey people who live in the oceanfront condominium in the city. Well, that has to be random because this is random right there, right? So is that a complete random survey?
No.
Well, why not?
Because it's in general. I mean, it's random from that, but it's not random out of the whole city.
Does the entire population live in oceanfront condominiums? So does everyone have an equal chance of getting picked in the survey? No, they don't. In fact, this would probably be skewed a little bit too, because who probably lives in an oceanfront condominium? People with more money. So you're basically saying if you're making a lot of money, we're going to take your opinion, everyone else, whatever. So that is not a fair way to come up with a random sample. Although it says random in it, it's not a completely random sample because it's a random of a specific location. You basically narrow down the population to 10% and go, okay, I'll randomly select from 10%. So that one's not random. Next one says survey the first 200 people whose names appear in a city's telephone book. Is that a random sample? This one's a bit tougher. Bill, you want to take a shot?
I want to say yeah.
You want to say yeah?
Because, I mean, there's no randomness around, like, names, and it's all throughout the city, so.
Okay. Who says no? Ethan?
It's not, I mean, it's just the first 200 people, I would say it's random and everybody
Yeah, does everyone have a fair chance to get picked? If I just pick the first 200, so it says the first 200 in the phone book. What if my last name is Zed? Did I even have a possibility of getting picked for that survey? No. So this would not be random. It kind of looks like random at first because it's 200. I don't know what 200 people I'm picking. But not everyone has a fair chance of getting picked. So this, in fact, would not be a good way to sample. And I think an easy way to look at this for people that still think it's kind of random, what if every survey was based upon the first 200 people in a phone book? It would always be the same 200 people. That's how we know it was not randomly selected. All right? I think going to that scale kind of puts it in picture that it's not random because it'd be the same thing. Let's change this one a little bit. Let's change this one a little bit, and we'll talk about how it would work now versus back then. What if I changed it to, I'm going to randomly select 200 people from the phone book? Yeah.
That would work because everyone has a fair chance now.
Right. Unless you dig deeper into that.
And you don't have a telephone.
Alright.
How many people aren't listed in phone books anymore?
A lot.
So let's look at 1970. We'll go back to 1970. Everyone that had a phone number was in a phone book because that's what they did. The phone company put these things out and put your names on it. So you at 99.9% of the population had phone numbers in the phone book. Do you think we're at that rate now? How many of you have phones? How many of your phone numbers are in the phone book? If you don't know, it probably isn't if it's a cell phone. So nowadays, even if I say randomly select from phone numbers in a phone book, we're still limited to 75% of the population. Am I saying that's a wrong way to do it? No, it might be the only feasible way to do it. But it's not 100% random sample. And our goal is always to get to the most random as we can. So let's go to that third choice. The third choice says randomly select neighborhoods. All right, everyone lives in a neighborhood. All right, so I'm just going to randomly select some neighborhoods. And then I'm going to randomly select some people within that neighborhood. Does everyone seem like they have a fair chance of getting picked in that one? Yeah, that's about as close as we're going to get to a 100% random survey as we possibly could. So this would be the one I picked. Are there flaws in this?
Yes.
Probably. In fact, if you look at what the next stuff talks about, how many homeless people are going to be in this?
If you don't live in a neighborhood, if you're just a solo house on the street.
Or if you're a solo house on the street. Yes, there's also rural places that don't fall into neighborhoods. So there are some flaws, but this is the best way we can do it. All right, so C is the best of our choices. As we talk about this, you're going to realize that there is no 100% random sample. There's always going to be some kind of bias or someone left out. We just do as best we can as statisticians. All right, example 3 says a city government wants to conduct a survey among the city's homeless to discover their opinions about required residence in city shelters from midnight until 6 a.m. A city commissioner suggests obtaining a sample by surveying all the homeless people at the city's largest shelter on Sunday night. Is this a random sample? So if I randomly select homeless people at the city's largest shelter on Sunday night, is that 100% random sample of the population? Yes. What if you go to one of the side ones, right? If you're a homeless person, do you think you're going to go as far as you can to get to the biggest one? Or you probably go to the closest one, right? All right, so that's a knock against it. It's one location. What about the fact that it has to be on Sunday night? Yeah.
Something that could be like a sleep or like a church on Sunday night.
Yeah, no, that's 100% true. Churches put on extra things for homeless people on Sundays. They put on their own soup kitchens and stuff. So Sunday night, it might be a terrible time. You might have a lot less people. They might be going to their church things. Also, you guys might not know this, but homeless people actually have routines where they go to specific locations on specific nights because populations swell on bigger ones, so they go to the smaller ones. So maybe the population swells on that night and they never go to Sunday night ones. So that person doesn't have a fair chance of getting picked. So this is definitely not a completely random sample. What might be a way to fix that? What might be a way to make it a little better and more random? Yeah.
Just go around shelters.
Go around shelters, right? Yeah. What if we randomly select some shelters? What if we randomly select some shelters and we go there on some random nights? Maybe more than one night. Maybe I pick 2 nights to go to. So that'd be a much better way to get a random sample. Random shelters on random nights. That would be the answer I put down, but let's be devil advocate. Who do we leave out? Yeah.
The ones that live on the streets.
People that just don't go to shelters. Unfortunately, is there an easy way to get people that don't live on shelters? How do you find, you know what I mean? So that would probably be our best case scenario, but know that anytime we have a random sample, there's usually someone that's left out. We just do as best we can. All right, any questions on these 3 or this question? It doesn't seem like we did, but we talked about a whole bunch of stuff on here, important stuff. Particularly about when you read statistics. Know that there's a lot more back there than you can read. All right, so the last thing we're going to talk about is frequency and grouped frequency distribution. What frequency actually is how many times something occurs. All right, how frequently do you go to the store in a week? I go to the store 3 times a week. All right, that's what frequency is. How many times does something happen? So let's go over this. So suppose you're a researcher interested in determining the age at which an adolescent male showed the greatest rate of physical growth. A random sample of 35 10-year-old boys is measured for height and then remeasured each year until they reach 18. The age of maximum yearly growth of each subject is as followed. Now, if I just showed you this data, can you infer anything from just looking at it? No, and data almost never is. That's why we organize it. And what we're going to do is we're going to organize it into something called the frequency distribution, which is also called the frequency chart. What a frequency chart is, basically what we're going to do is we're going to look at, real quick, each of these are called a data item or an item of data. We're going to look at all of our data items and we're going to count how many times it occurs. When we're making these charts, on your homework you have to make this all by yourself. You won't have this list over here. You're going to have one thing listing in this case it would be our ages, our data, and then in the other one we're going to list how many times it occurs. To do our left-hand column, you're going to find the smallest number that occurs, which is 10, right there. And you're going to start at 10. This is going to be called your lower limit. That is your lower limit. Then you're going to count up. You're going to go 10, 11, 12, 13, 14, 15, 16, 17. And then you're going to eyeball it and hopefully come up with your biggest one. Sometimes you make a mistake and you have to keep adding rows. Or columns, no, they're rows. But in this case, I already told you it's going to be 18. 18 is right there, so that's going to be our upper limit. So you're going to start at your lower limit, and you're going to go all the way to your upper limit. And then in that frequency table, you're going to say how many times does age 10 appear. Now, the easiest way to do this, hardest way is to go to 10 and find all your 10s and cross them out because you're going to miss stuff. Here's the easiest way to fill out a frequency table. We're going to start at 12. And what I'm going to do is I'm going to cross it out to say I counted for it. And what we're going to do is we're going to go over to 12. And not in the box. You can if you want to. You can do this opposite. But at 12, over to the side, I'm going to put a little tick mark and say it appeared once. Then I'm going to go to 14. I'm going to cross out 14, go over to 14 and put a tick mark. Then I'm going to cross out 13 and put a tick mark on 13. 14, put a tick mark. 16, put a tick mark. And as I'm crossing them out and putting them down, I'm going to count for all of them. You're much less likely to make mistakes that way. Yes? We're going to actually put numbers in the box. But it is okay if you put your ticks in the box and just put your frequency, just come up with a third thing that says frequency over here. Because you should have eventually just numbers that we can see. As long as if you can fit your tick marks and your number in here, that's fine too. Okay? I want you to go ahead and finish off this table. I'm going to write the values up here. I might not necessarily write the right ones. So if we got something different, just hold on to it. We'll figure out as a group which one's right, which one's wrong. So we're going to add up our entire frequency column, which if we added them all up, we'd end up with 1 plus 2 plus 5 is 8, plus 7 is 15, plus 9 is 24, plus 6 is 30, plus 3 is 33, 34, 35. That would equal 35, which is the number of boys in the sample. So my bet is, Will, if you would have added these up, you would have came up with 34.
Yeah.
And then you have to go back to it's the worst when it doesn't add up, because then you basically have to do it all over again because you don't know which one you missed. But at least you can catch that mistake. Just so you know, I'm not worried about you being like 1 or 2 off, as long as we can do the same thing. Because what I'm going to do next is, this is descriptive statistics right now. That is numbers on a chart. Can anyone infer anything from this? Turn this into inferential statistics? Yeah.
The greatest growth for boys is at 14.
Yeah, the greatest growth for boys is age 14. That is inferential statistics. I am looking at the data and I'm inferring that, hey, about the age 14 is where most boys grow the fastest, based upon a sample size of 35. Now, if I'm doing the whole population of all the boys in, say, United States, is 35 a big enough sample, do you think? Probably not, especially because it's at one location. But we can still infer that from this data. All right, the last thing we're going to talk about is a grouped frequency distribution. There are times where you just have too much data to just put individual numbers to it. So consider this. We have 40 students who took a test, and their test scores are down here. It's not going to help me too much to list that we have 182, 147, because mostly it will just be ones all the way down. That's not going to help me too much. So as a teacher, I'd want to group these into important groups. All right? We're going to group these into groups so we can see which group has the most numbers in it. In this case, probably a good grouping would be grade. A, B, C, and D. And we're going to go ahead and use our Brookfield Academy scale. So these are going to be called classes. Your groups are called classes. So we're going to go, 100 to a 93 is an A. Then we'll go 92 to an 85 is a B. Then we'll go 84 to 77 is a C. Then we'll go 76 to 70 is a D. And why would I possibly change that last group? Each of the other groups are about the same size, but that last group is different. What was that? Is an F, right? Maybe I just care about things being Fs. Most of the time, your class sizes are going to be all the same. Normally we do, go 69 to 62 and so on and so forth, counting at the same level. But in this one case or specific incident, I just want to know who got an F. Okay, does that make sense? Are we on board on that? Okay. All right, so now we're going to count those frequency. Now, real quick, these are called class sizes. So in this case, our class size would be 7 for the first 3. It'd be 6 for the fourth one, and it would actually be 69 for the last one. Class size is the difference between the top number and the small number. So sometimes when I ask you to come up with one, I might just say the class size is 7. Or I might give you the first class size, and you have to repeat that over and over again. I see most of you are already on your way to doing this. Just like the other one, we're going to find that number, 82. I'm going to cross it off. And I'm going to tick mark where 82 would fit. Well, 82 is somewhere between 77 and 84, so I'd put it in the 84 to 77. 47 is below a 69, so we'll put that in that one. 75, that is between a 70 and 76, so I'd put a tick mark there. Then we had a 64. 64 is less. Go ahead and fill out the rest of that chart. And then we'll be done for the day. Or the week. We only have like a minute and a half left. Does someone have how many people got A's? Sahej? 4. How many people got B's? Stephanie? 3. How many people have C's? Anyone else finish this? Life? 8. We'll see. How many people got D's? Anyone got the D's? Sam? 8. How many people got F's? 15. Okay, we'll go back and say, so C might be wrong.
And I had some for 76.
So we had 10 for this one. 16F. This is actually correct as written right here. It should be 4, 3, 10, 8, and 15. Sometimes the group is the hardest one because some of us like to do several at a time, and it's hard to remember what group stuff went in. So be careful. Now, whenever you finish this, always add all these up to make sure it works out. So we're not packing up. I didn't say it's time to go. So we're going to add all of these up. We'd have 7 plus 10 is 17, plus 8 is 25, plus 15 would equal 40. That was the sample size we started with, was 40. All right, your homework today for the weekend. It isn't that bad. The front side should go pretty quick. It's mostly just words and kind of short answers. It shouldn't require a ton of work on your part. The back side will be a little bit more work on your part. You have to make these frequency charts. To our group ones and to our regular ones. I only started one for you. The rest you have to do the entire thing. Although not difficult, can be kind of mind-numbing because it's a lot of just tallying stuff up. Get it done, guys. All right. Have a good weekend.